If you look at enterprise AI right now, it is experiencing a staggering 95% failure rate when moving from the pilot phase into production. I mean, 95%.
That's an incredible drop-off.
Right. In literally any other sector of the economy, a failure rate that massive between testing a concept and actually deploying it, that would trigger a complete halt to funding.
Oh, absolutely. People would be slamming the brakes.
Exactly. Firing the consultants, doing a total reassessment of the whole strategy. Yet, in the AI space, companies just keep launching more pilots, hoping the next one magically survives the jump to the real world. So, welcome to the deep dive.
Glad to be here.
We have a really fascinating mission for you today. We've gathered this massive stack of highly detailed architectural analyses, research articles, and technical reports diagnosing this exact failure. And we're going to uncover the true structural reason behind this massive drop-off.
And more importantly, how the successful 5% are actually pulling it off.
Yes, exactly, because someone is getting it right. But I guess to start, it's wild to me that people just keep doing the same thing.
Well, the persistence of these pilot programs, it really reveals a fundamental misdiagnosis across the industry. When an enterprise AI project stalls out, the postmortem almost always focuses on organizational friction.
Like office politics and stuff.
Exactly. The executives blame change management, or they point to a lack of internal sponsorship, or maybe they claim they just didn't pick the right initial use cases.
Or they blame the talent, right?
Right.
Like, oh, we don't have the right engineers.
Right. Some blame a talent gap. And, those are real hurdles for any transformation, but they are entirely the wrong diagnosis for this specific systemic failure.
Okay, so what is the right diagnosis?
Well, the data shows the problem isn't a lack of budget. It's not a lack of engineering talent. And it is certainly not a problem with the AI models themselves. I mean, the models have never been more capable.
So wait, if the models are brilliant and the vendors are top tier and the budgets are essentially blank checks, something structural must be killing these projects the second they leave the lab.
Exactly. We have to look at the exact moment the failure occurs, the transition from the controlled environment of the pilot into the live operations of the enterprise.
The real world.
The real world. The models are basically being asked to perform on data that simply cannot be trusted. In the pilot phase, the data looks spectacular because, well, it's artificially perfect.
Because someone cleaned it up.
Right. A human being painstakingly curated every single row before the AI ever even saw it.
Let's visualize what that curation actually looks like, just to make it tangible. The data scientists running the pilot, they're manually resolving ambiguities, right?
Yeah, they're fixing null values, translating legacy codes.
And throwing out the weird edge cases that don't fit the expected pattern.
Yeah.
They're basically pre-digesting the information for the AI.
They are acting as a translation layer. But here's the thing in production, that human translation layer disappears. The AI is suddenly fed the full, messy, inconsistently maintained, semantically complex output of the source systems.
The systems that the business actually runs on day to day.
Exactly. And the architectural analyses we're looking at, they summarize this perfectly. One of them says, and I quote, "The pilot works because someone curated the data. Production fails because nobody can curate everything continuously at transaction speed."
Wow. Okay, I love that quote. It makes me think of, imagine a world-renowned Michelin star chef.
Okay, I like where this is going.
Right. So during the pilot phase, you place this chef in a pristine test kitchen. All the ingredients are pre-measured in little glass bowls. The temperature is strictly controlled, zero distractions. They're going to produce an absolute masterpiece.
Obviously.
But for the production phase, you take that exact same chef and drop them into a chaotic restaurant kitchen during a holiday dinner rush. Half the ingredients are mislabeled. You hand them a jar labeled sugar, but it is actually salt.
Oh, man.
The ovens are running hot, the prep staff speaks 4 different languages, and the tickets are printing in shorthand. The chef didn't suddenly forget how to cook, right? The environment failed them.
That is a perfect analogy. What's fascinating here is that the chef's culinary skills represent the AI algorithm, and that messy kitchen is the enterprise data architecture.
Yeah.
You cannot fix the chaotic kitchen by sending the chef to more cooking classes. You have to reorganize the entire kitchen.
Just to fix the environment.
Exactly. This distinction is critical because it shifts the focus away from, fixing the AI to fixing the infrastructure holding the AI. The model that ran in the pilot is the exact same mathematical model failing in production.
The only variable that changed was the data environment.
Right.
Okay, but let me put myself in the shoes of an IT executive listening to this right now. I would immediately think, wait a minute, we have spent the last decade and literally millions of dollars
Hmm.
building data lakes and centralized data warehouses to solve this exact messy kitchen problem.
Oh, the classic data lake defense.
Yeah, because the entire pitch of the modern data architecture was that you extract all your raw data from various source systems, dump it into one massive centralized pool, and boom, your data is instantly accessible and ready for analysis.
Yeah.
So why doesn't that solve the problem?
Well, the data lake became the most common architectural pattern because it solved a completely different problem. It separated heavy analytical workloads from live operational systems, so you wouldn't crash your servers just running a weekly report.
Right, okay.
But relying on it for enterprise AI is fundamentally an illusion. When you extract business data out of an ERP system, and by ERP we mean enterprise resource planning software, the core digital nervous system where the real-time financial and supply chain transactions happen, you are severing that data from its context.
Because the ERP is the native habitat of that data. It's where the data actually lives and breathes.
Precisely. In its native habitat, a revenue figure isn't just a floating integer. It's bound by complex, invisible rules.
Can you give an example of what those rules look like?
Sure, let's trace a specific transaction. Imagine a multinational company processing a transaction between a French subsidiary and a Japanese supplier.
Okay, sounds complicated already.
It is. Inside the live ERP, that transaction is tied to dynamic exchange rate logic, specific European tax codes, and intercompany elimination rules that dictate how it impacts the global balance sheet.
Okay.
Plus, it's governed by temporal rules that determine if this transaction is current, pending, or even reversed.
But when you extract that transaction and dump it into a data lake,
You trigger a process known as semantic decay.
semantic decay.
Yes. It's the progressive loss of business, meaning that occurs as data moves further and further away from its system of origin. By the time that complex French-Japanese transaction lands in the data lake, all that active, dynamic logic is just stripped away.
It's gone.
It becomes a static, flat number, say $10,000 with a timestamp and a few metadata tags attached to it.
And metadata is really just a label on a jar, right? It tells you what the data is called, but it doesn't give you the recipe for how it interacts with everything else in the kitchen.
Exactly. The source material is absolutely adamant on this point. Metadata is not meaning. An AI model attempting to analyze that data lake cannot reverse engineer the corporate tax structure or the currency conversion logic from a timestamp and a tag.
Because it's literally just looking at a degraded approximation of your financial reality.
Right. And semantic decay is entirely invisible during a pilot because, as we established earlier, the human curators manually restored the meaning for that small sample size.
They put the context back in.
Yeah. But at production scale, the AI is starved of context, misinterprets the degraded data, and fails.
Okay, let's unpack this. Because if pulling the data out of the source system is what breaks the context, then the logical alternative is to just leave it where it is. But you obviously cannot unleash an experimental AI directly into your live mission-critical financial systems without breaking things, right? So how are the successful 5% solving this paradox?
They solved it by introducing what is called a canonical data layer.
A canonical data layer.
Yes. Instead of extracting the data to a secondary location like a lake, they build an interpretive layer that sits directly on top of or adjacent to the source ERP systems. It standardizes the data in place.
Wait, how does that actually work mechanically? How do you standardize something without moving it?
Think of it as a highly sophisticated real-time translation lens. As every single transaction occurs in the ERP, the canonical layer maps those disparate, messy data fields to a common standardized data model instantaneously.
So it's translating on the fly.
Right. It doesn't physically relocate the database. It normalizes the field definitions, strips away local idiosyncrasies like, one department using the word client and another using customer, and preserves that vital business context.
Okay, I see.
It creates a single authoritative version of the truth that the AI can read safely without ever touching the raw underlying code.
So this canonical layer is essentially a strict bouncer at an incredibly exclusive club.
I love that, yes.
Let's say the AI system is the VIP section. The bouncer stands at the door and ensures that absolutely no raw, unverified, or semantically degraded data gets through. You either meet the dress code, meaning your data is completely standardized and contextualized, or you just don't get into the VIP section. It forces total standardization before the AI is even allowed to perceive the information.
And to enforce that dress code, the successful 5% institute a strict architectural mandate. It's known as the intelligence exclusivity rule.
The intelligence exclusivity rule.
Yeah. This rule dictates that no AI system, under any circumstances, is allowed to operate on raw data that hasn't passed through the canonical layer.
No exceptions.
None. If an AI agent attempts to bypass the bouncer, say, by accessing a direct extraction from some legacy system that wasn't normalized, its outputs immediately become untrusted. You simply cannot govern an AI if you cannot govern what it reads.
But implementing a bouncer that's strict implies the environment behind the door is relatively orderly to begin with, right? You can't put a canonical translation layer over an ERP system that is completely chaotic and held together by duct tape.
Oh, absolutely not. Which brings us to the prerequisite of this entire architecture, the clean ERP environment. Over the decades, a lot of large enterprises have heavily customized the core systems. They bury compliance rules deep in the custom code. They use these fragile things called Z programs.
Z programs?
Yeah, they're highly specific, custom-built tweaks that tend to break every single time the vendor updates the main software. They have all these country-specific configurations that bypass standard logic.
It sounds like a nightmare to manage.
It is. And a canonical layer cannot translate chaos. The data flowing out of the ERP has to be standard and predictable so the translation lens can actually work, which means companies have to do the hard work of stripping out those brittle customizations and returning to a clean, standardized core.
Yeah, you cannot build a skyscraper on a cracked foundation.
Yeah.
The architecture has to be sound before you add the heavy machinery.
Precisely.
Okay, so let's assume an enterprise has done the hard work. They have the clean core, they have the canonical layer acting as the strict bouncer, and perfectly contextualized data is flowing to the AI. We need to explore what the AI actually does with this pristine data, because this is where the industry shifts from how AI thinks to how it acts.
Right, and this is a massive shift. We are witnessing the transition from the first generation of enterprise AI to a much more mature phase.
Okay.
The first generation was built on what we call a chain of thought architecture.
Chain of thought.
Yes. In this model, the AI analyzes the data, generates insights, summarizes massive documents, and, makes recommendations.
Like a chatbot.
Exactly. It produces outputs designed for human consumption. The human being remains the primary actor who has to actually manually execute the recommendation in the system.
I mean, having a hyper-intelligent digital assistant summarizing your complex data sounds incredibly valuable, though. It's what most people picture when they think of AI in the workplace.
It does provide immense value, but it hits a structural wall, which the sources called the throughput ceiling.
The throughput ceiling.
Yeah. No matter how fast your AI generates recommendations, if a human being has to manually review, approve, and execute every single one of them, the speed of your organization is strictly limited by human cognitive capacity.
Right, because I can only read so many emails a day.
Exactly. The AI is essentially just generating a massive to-do list faster than anyone can read it. You are bottlenecked by the speed of human review.
It's like having a robotic assembly line that can manufacture 1,000 parts a minute. But at the very end of the conveyor belt, there is one person with a clipboard manually inspecting and boxing each part.
That is exactly it.
The theoretical speed of the robot is entirely irrelevant because the factory can only move as fast as the person with the clipboard.
Right, and the successful 5% recognize this bottleneck. So they move to a chain of action architecture.
Chain of action. Okay, so how is that different?
In this model, the AI doesn't just generate recommendations for a human queue. It is authorized to take action within the enterprise systems directly.
Wait, really?
Yes. It independently resolves invoice mismatches, it applies correcting entries to the ledger, and it handles end-to-end processes completely autonomously.
Okay, I really want to pause on that because the risk profile just shifted dramatically.
Yeah.
An AI hallucinating a weird marketing email is embarrassing, sure. But an AI autonomously hallucinating a $1 million accounting entry or altering a supplier's payment details without human intervention, that is an existential threat to the company.
Oh, without a doubt.
So how is a CFO or an audit committee ever going to sign off on an AI taking independent financial action? That sounds terrifying.
It does sound terrifying until you realize how they build it. The most sophisticated organizations realize that the defining question is not, can the AI be trusted not to hallucinate?
Then what is it?
The defining question is, can the AI be strictly governed? In a chain of action architecture, trust is mathematically enforced. The AI operates within incredibly narrow, predefined parameters, and it produces a cryptographic audit trail for every single micro-action it takes.
A cryptographic audit trail. How does that function on a mechanical level? Like, what is actually happening?
Well, when the AI decides to apply a correcting entry, The system cryptographically hashes the input state, meaning the exact data the AI looked at in the canonical layer.
Okay.
It records the specific decision weights and rules the model applied at that exact microsecond, and then it logs the final output action into an immutable ledger.
So it's permanently recorded.
Exactly. If an auditor asks why a $1 million entry was made, nobody has to ask the AI to explain itself and just hope it tells the truth. The entire mathematical chain of logic is frozen in amber and fully traceable back to the canonical truth. You are trusting the unalterable cryptographic trail, not the black box of the AI.
Oh, wow. That reframes the entire concept of AI safety in a corporate setting. You're not trusting the brain, you're trusting the receipts.
Precisely.
So if we zoom out and look at this entire ecosystem, if we have AIs independently taking financial actions, leaving cryptographic trails, and reading from a canonical layer, what does the overarching corporate structure actually look like? Is there just one massive omniscient intelligence running the entire finance department from some central server?
No, actually, the mature architecture is the exact opposite of a single monolithic brain. The sources describe it as an internet of agents.
An internet of agents.
Yes. It is a distributed network of highly specialized AI agents working collaboratively. So, one agent is strictly confined to managing VAT positions. Another agent is entirely dedicated to spotting anomalies in procurement.
Oh, I see.
Another handles cash flow forecasting, while a separate agent manages intercompany reconciliations.
So it's a highly specialized team of autonomous experts rather than one generalist trying to juggle every discipline at once.
Exactly. And the design logic here leverages both depth and scale. Specialization allows an agent to achieve incredible depth in a narrow domain. An agent focusing only on VAT regulations becomes flawlessly efficient at it.
That makes total sense.
And because these agents are all operating on the shared foundation of that canonical data layer we talked about, they communicate seamlessly. The procurement agent spots an anomaly, tags it, and the cash flow agent instantly adjusts its forecast based on that shared, standardized truth.
That's wild. But wait, if these distributed agents are instantly validating transactions and reconciling accounts in real time, that completely obliterates the traditional timeline of corporate compliance.
It really does.
Like, you don't need a frantic month-end close if the books are continuously balanced.
You've hit on one of the biggest outcomes of this. It ends the traditional audit cycle as we know it. Historically, compliance is a periodic, retrospective scramble, right?
Oh, yeah, totally.
Teams let transactions pile up for a month, then spend weekends assembling evidence of what already happened just to prove the ledger is accurate. But we are shifting toward an era of continuous transaction controls, or CTC.
The CTC, okay.
Many global governments are already mandating that invoices be validated instantly at the very moment the transaction occurs. So the Internet of Agents maintains a continuous financial position. The formal month-end close transforms from a chaotic sprint into a mere procedural formality.
Okay, let me play devil's advocate here, because this is where it gets really interesting for the people actually doing these jobs. You're painting a picture where the month-end close becomes a formality because agents balance the ledger in real time.
Right.
But auditors don't just check the math, though. They check human intent. An AI agent might balance a ledger perfectly, but how does it know if a transaction was initiated with fraudulent intent or if an expense was intentionally misclassified to hide a massive strategic failure?
That is the crucial limitation of the agents, and it actually brings us to the future of the human workforce.
Because everyone is terrified of losing their jobs to this, right? Do the finance professionals just disappear?
The sources emphasize heavily that this structural shift is not a massive headcount reduction strategy disguised as technological progress. The human organization does not disappear. It elevates.
Elevates how?
The role of the finance professional shifts fundamentally from process execution to intelligence governance.
Intelligence governance, meaning they oversee the system rather than operate the machinery.
Exactly that. Humans are no longer wasting their cognitive capacity matching rows in a spreadsheet to reconcile some minor discrepancy.
Thank goodness.
Right. Instead, they are the ones setting the strategic parameters for the agents. They are investigating those complex edge cases that the AI flags because the intent seems suspicious. They are monitoring the cryptographic audit trails for systemic bias.
So they become the detectives and the strategists.
Yes. The human workforce focuses entirely on high-level judgment calls, fraud detection, and organizational strategy. You stop being the person pushing the buttons on the calculator, and you become the architect overseeing the ecosystem.
That is such a powerful shift. The ultimate takeaway from this deep dive really is Remarkably clear, and I think it serves as a powerful warning to any enterprise currently dazzled by the latest AI capabilities. The 95% of projects failing to reach production are failing because they are treating AI as a standalone software tool that can just be dropped into a messy environment. They
Exactly.
are starving the AI of context, feeding it decaying data extracted into data lakes, and honestly just expecting miracles.
While the 5% who are extracting immense financial value did not start by buying the flashiest AI model,
Right.
they started by building a canonical foundation of standardized, real-time truth. They built the clean ERP core, they enforced the intelligence exclusivity rule, and they established the cryptographic governance required for agents to actually act autonomously.
Fix the architecture, and the AI will follow. That is the structural reality. I want to leave you with a final, lingering thought to mull over as you analyze the systems you use every day in your own work. Look closely at your organization's infrastructure. Are you building your future strategies on a true canonical foundation of standardized truth? Or are you just building on sand, expecting a shiny new tool to magically fix the chaos underneath? The next time someone pitches you a new AI tool, don't ask what the model can do. Ask what data it's drinking from. Thank you for joining us on this deep dive. We will catch you next time.